Okay, it's pretty much a mess what I got going on right now, but I wound a pancake using, I believe, RG6 or RG5 coax, and lost my connection there, but I got about 18 turns, and I can appreciate how fun it is to go through that process of winding that coil. Anyway, slider simple wireless system here, and pretty happy with the results of the bigger coil, the BAC. And but I will say I had to play around with this guy to get it to work the way I want it to work. But as it is now, getting much better light than I was from obviously my AA setup, so the power transfer is pretty good. Getting really good distance. Takes a while before that guy fades away there. So yeah, pretty decent distance there. And I'm running it from 6 volts right now off this guy right here, this battery here. And it's pulling 22 milliamps loaded with this guy right here. If I take the load off, it's pulling about 17 milliamps, and that's about as low as I can get this guy. Get him about, let's see, I can bring this guy, the way I have it set up, to about 10 milliamps. About 10-11 milliamps or so. It's about as low as I can get him to oscillate and still give off a field that'll light this light bright. But it's pretty effective off that. It brings it up to about 15. But it'll also work from 20 milliamps the same way it does here off of 12 volts, and the field is much greater and more power is transferred. But the only way I was able to get it to do this is by using the same setup I had before with the pot and the capacitor. I'm using a 2N3055, and I've got the solid copper conductor of the coax is my drive coil. That's going to the collector, and then the braided middle ground wire, which is that stranded braided wire that's touching the dielectric, that's going to my base. And it makes a difference which one you use, but this way worked the best. And the only way I can get this circuit to oscillate the way it is with the low draw and still have the good field is by using a combination of this 5K pot, this small capacitor, which I still am not sure. I believe it's a nanofarad capacitor. However, 10 microfarads also put it in a decent range where it acted sort of similar but not quite the same. The 10 microfarad DC cap was giving me blinks also, but this guy right here works really good. See, if I take it off, the draw goes up to about 43, and at that 43 the LED will not even light up. I'm just not even getting anything there at all. And then if I put the capacitor back on in parallel with my 5K base resistance, then the light does come on bright and the draw shoots down. So that was actually necessary, and when with that setup I can slide it all the way up to a higher brightness, up to about 75. Well, I can fine tune it up to about 100 there, and then beyond that it starts shooting up dramatically up in the 200, 300, which if you want, I would be comfortable running at that because I know I would get more power transfer. But just as it stands, I like running it as low as it'll go. Look, right there it's actually saying it's pulling 3.5 milliamps. I just happened to get that right that tuning right down there with some good oscillation, and that's actually still bright. But it's not often I can get it to go in that region. So if I turn it off, plug it back in, it's still there. Cool. So now, before, it's actually kind of self-oscillating when it's super high resistance, because the resistance right now is ridiculously high, and that capacitor by itself managed to maintain the oscillation. So that's what it's pulling right now, with pretending as if that capacitor is in series with my base. Without that capacitor, it wouldn't do that. So I'm getting a super low draw there. That's pretty cool. So 3 milliamps I'm able to get. Of course, there's no range there. Anyway, I like to bump it up to about 15 or so. That's where I get the real good light and the good range. But like I said, I also ran this from 12 volts, and I was absolutely shocked that, you know, I was in my 500, 600 milliamp range. I was getting roughly the same draw. It wasn't really burning out my LEDs, my 3-volt LEDs, but it was very, very, very bright. And then as soon as I tried the combination of the high-speed switching diode that Slider recommended on the input, and then this capacitor, everything, the draw shot down to, you know, 15, 20, and the LED was the same brightness. So I really couldn't believe that. But this is kind of my first little play around recording the draw here of this. So I'm getting really, really good results with the combination of the diode and the cap. Just to show you, so I took the capacitor off. Now let's bypass this diode. Now its draw is 45 milliamps. The brightness of the light is roughly the same. Then the pot is a lot harder to adjust, because now with the resistance all the way up, I'm still pulling that 34. Without that diode, I can't really get it below 30 milliamps or so. So using that diode, it keeps it down to a suitable tuning region. If you really wanted to use this for something, for example, just something that you can sit there and idle off of a battery and not be called upon until you introduce the load, which would be like one of these cool guys here. And I'm pretty sure I'm getting fairly significant power transfer there. And I know with this setup, unlike other setups that I tried, I really could brute force it with the 12 volts and not have to push more than a couple hundred milliamps. So I'm pretty sure I can easily charge a phone that way. Yeah, just simple setup there. It seems to be working for me. About 18 turns of the bifilar pancake 2N3055 or similar. The high-speed diode across your input. And then a 5 to 10K pot as your base resistance with a very small value capacitor in parallel. Seems to do the trick. Alright, thanks for watching.